All right, I want to go back to 2014 problem and show you number 3. And the reason for that, I think I mentioned in the email I sent you. I don't know, I just kind of troubled. I just felt that I really need to give you one more of these. I mean, I'm not saying I've got some kind of inside edge on what the question is going to be. I just really want to make sure I gave you one more of these. So this is the problem. It says a student is given a standard galvanic cell shown below. Identify the electrode which oxidation is occurring. Explain your reason based upon the student's observation. But I just put the reactions here because what we're told. So here we got reduction occurring, oxidation, and so it's that's what I put. It says since it's stannous electrodes losing mass, atoms must be forming. So this is oxidation. Also, you know this has to be happening since it's making electricity. So any one of those things would be acceptable on that. As the mass of the stannous electrode decreases, where does the mass go? Well, it goes into solution. I mean, this is losing ions, so the ions are going into solution. So that's all they're after there. Now on C, it says expanded view of the center portion of salt bridge, which I put there. It says draw and label a particle view of what occurs when the salt bridge itself begins to operate. Omit solvent molecules and use arrows to show the movement of particles. Well, basically, this is to the copper side. So the potassium ions are going to be going in this direction, and then the nitrate ions are going to be going towards the stannous. Again, you have positive here, so the negative is going to go that way. Here you've got positive here. Excuse me, you're having the electrons here, and so it's going to move in this direction. Now, do not show the electrons moving in there. They will actually deduct points. It says so they will deduct points. You try to show the electrons moving. Okay, in D, a non-standard cell is made by replacing the 1 molar solution, the standard cell, with 0.5 molar solutions. The volume of the solutions are identical to those. Is the cell potential of the non-standard cell greater than, less than, or equal to the cell potential of the standard cell? Well, you know that from our Nernst equation that E equals E standard minus 0.0591 over N times the log of Q. Well, in this case here, the ratio is the same. Okay, it's still 0.5 to 0.1, so Q is going to end up being 1, so the stand potential has to be the same then, right? Because if you realize the potential is the same, and you do the log of 1, this whole thing becomes 0, so the potential is the same. But it says, would the non-standard, in part 2 says, would the non-standard cell be the same or shorter compared to the standard cell? Well, it's going to be less than because you have fewer copper ions. Okay, we had 1 molar to begin with. This we got a half molar, so you get fewer copper ions for this reaction to occur. Therefore, it's going to run out faster, so it would be less than. So again, so for the potential will be the same because this ratio is the same, making this value 0. But again, just knowledge saying I've got a lower concentration of ions, therefore it's going to be a shorter length. It's going to last a shorter time. Okay, in another experiment, a student places a new electrode. Whoops, did I do that one? Yeah, I'm on E now. And they give you some reactions. Write a net ionic equation for the reaction. You're told that it's happening. So I put stannous minus 2 electrons, like I've got up there, yields plus 2. That's my oxidation reaction, and that's going to be a positive 0.14 voltage. And then the copper, of course, stays the same. And that's given to us as 0.34 volts. And so you have 0.48 volts. And that is your reaction potential. And it says, using information, write the equation. Well, thermodynamically favorable means it's going to happen. It's moving in the right direction. So, yeah, so you have to make sure it's a positive value. If you flip this one, you get a negative value. That cannot happen. And then, they asked for, did it ask for a net ionic equation? Yes, it does. I apologize here. So you got to have then Cu plus 2 plus stannous, or stannic, 10, sorry. Stannous ion plus copper, showing the electrons cancel out. Okay, then part 2, it says calculate delta G. delta G equals N, negative NF. Standard potential, N, is you have 2 moles of electrons. So you have 2 moles of electrons per mole of reaction. And you get 96,485 coulombs per mole of electrons. And I told you in the thing that don't forget that a volt is a joule per cool. So you get 0.48 volts, so 0.48 joules per coulomb. And then 1,000, sorry for stretching frames so much, to 1 kilojoule. And this equals negative 93 kilojoules per mole of reaction. Moles of electrons cancel, coulombs cancel, joules cancel, kilojoules, and this is per mole of reaction as they told us, because they say for the reaction. So anyhow, I hope that helps. I really felt this is what I wanted to give you. So good luck with all this. Sorry it takes so long.